So a couple of examples. We'll say Dunder Mifflin has $100 cash on hand and is considering purchasing a new forklift. Purchasing a new forklift would cost $100 and have an expected increase in profits of $5 per year. Alternatively, Dunder Mifflin could put the money in the bank and earn 2% interest per year. So Dunder Mifflin has the money to buy the forklift, and if they can either buy the forklift or put the money in the bank and earn interest. Vance Refrigeration is considering purchasing a new forklift. Purchasing a new forklift would cost $100 and have an expected increase in profits of $5 per year. However, if it wishes to buy the forklift, it will have to pay an interest rate of 2% per year. Again, so now we see Vance Refrigeration, their cost of the forklift is the 2% interest they have to pay. Both projects have an expected rate of return of 5%. And in both cases, the opportunity cost of the investment is $2 per year. How do we get there? Well, Dunder Mifflin is giving up 2% interest. Vance Refrigeration is giving up on the chance to not borrow and therefore pay $0 in interest instead of 2. So you see what they're giving up, that's what opportunity cost is. So investments in your business often have a decreasing rate of return. So it's similar logic to decreasing marginal benefits. So we talked about how you like the second bite of ice cream less than the first bite of ice cream. Well, similarly, the second forklift will not be as valuable as the first. It's not going to be as important. You probably aren't going to have as much to do with it. And so imagine, like, what would Dunder Mifflin do with 25 forklifts? Michael would wind up driving one or something. Okay. So first top hat question. So I'll go ahead and start this, and I think somebody may have wanted me to go back to another question. So Regional Manager Michael Scott is considering purchasing up to 3 forklifts at a cost of $100 each. If he buys 1 forklift, he expects a total profit increase of $5 per year. If he buys 2 forklifts, he expects a total profit increase of $9 per year. If he buys 3, he expects a total profit increase of $11 per year. Interest rate's 3%. How many should he buy? Right. Answer here is 2. So this table here summarizes what we've done, everything that was in the problem. So we can, if we have 1 forklift, that benefits us 5, 2, 9, 3, 11. So something like this, we always compare marginal benefit with marginal cost. Our marginal opportunity cost is right here, $3, because that's our interest rate. For every forklift we buy, we have to pay 3% in interest, which is on $100 is $3. So now let's calculate marginal benefits. The marginal benefit is how much benefit do I get from the next forklift? Well, going from 0 to 1 forklift gives me $5. Next one, 5 to 9 gives me 4. 9 to 11 is an extra $2. So now we compare marginal benefits to marginal cost for each forklift. So the first forklift costs $5, benefits me $5, costs $3. Well, the five is bigger than 3, so I want to buy that first forklift. Check, getting that first forklift. Second one, $4 in benefit is greater than the $3 in cost, so I want to buy the second forklift too. Third forklift, it's going to benefit me $2, which is less than the $3 I pay. Remember, this is borrowing $100 for the forklift and paying 3% interest. 2 is less than 3, so I do not buy that forklift. The other way to think of it is, maybe more straightforward, is I have $100 on hand, and one of my options is to just throw it in the bank and earn $3 in interest. And I have to decide, is that forklift going to be better for me than just getting the $3 in interest? And the first 2 forklifts, the answer is yes. The third one, the answer is no. So the answer to the top hat was we're going to buy 2 forklifts. All right, well, let's suppose the interest rate goes down to 1%. None of this stuff changes. The total benefit doesn't change. The marginal benefit doesn't change. The extra amount of value I get from the forklift doesn't change. What does change is the opportunity cost. So how much less do I have to pay in interest if I'm borrowing, or how much less am I foregoing in interest? So instead of missing out on $3 in interest by not putting it in the bank, 1% interest means I'm only missing out on $1 in interest. So notice, so not the first 2, these are still true, right? 5 bigger than 1, 4 is bigger than 1. So we're definitely going to still buy those first 2. Now let's look at what has happened to that third forklift. Our marginal benefit of that third forklift is still $2, but now my marginal cost has gone down to $1. $2 is bigger than $1, so now I do want to buy that third forklift. So marginal benefit, again, way we get there is when we go from 5 to 9, our total benefit goes up by 4. We go from 9 to 11, total benefit goes up by 2. Okay, so let's think about what we just did. So when we're comparing the relationship between the quantity of investments, so how many forklifts, and the interest rate, which of those lines could represent what we call the investment demand curve, the relationship between the interest rate and the quantity of investment? The answer here is C. All right, sometime if I actually start doing it, if I actually figure out how to really do it, I actually play a game, I'll confirm to myself that nobody actually wants to watch, but appreciate the interest, at least thinking you're going to watch. So where do we get this? Well, the relationship looks like this, because as interest rates go up, investment levels drop. The same is true for the entire economy. So just like how Michael Scott, his company, when the interest rate goes up, they drop their investment. When interest rate goes down, we have more investment. This is true for the entire economy. High interest rates make new capital more expensive, both for borrowers and for firms with cash on hand. And this is important because capital is closely linked with growth. So when borrowing is cheap and it's easier for a business to borrow to buy capital, that's going to help growth, right? We talked about one of the factors in helping a country grow is making investments in capital. All right, so that is what we need to know about investment demand. Now we're going to think about investment demand along with government purchases and net exports. So all the components of GDP other than consumption. So we already looked at consumption. We said that when real GDP increases, so all the GDP increasing means all of us who are working in the factory are getting more money. Well, consumers spend some of the extra income and save the rest. So that we know about consumption. How about investment, government purchases, and net exports? So we've learned about the C. How about IG and NX? Well, let's think about consumption a little more. Consumption, you're always consuming something, even if your income is zero. That's what's going on right here, right? Even with no income, you would still buy something. And when real GDP increases, consumers spend some of the income and save the rest. This was the idea behind the marginal propensity to consume. The slope is positive, but less than 1. Why is that? Well, let's think about what happens if we get an extra $1 in income. If we spent all of it, that would put us up here. We're not spending all, but we're spending a little less of it. We're going to spend that much, and this much right here is how much we save. And we know even more than that because we know the amount that this goes up, which is our slope, is equal to the marginal propensity to consume, right? The marginal propensity to consume is how much of your extra income you spend. So now let's think about investment, government purchases, and net exports. How do they relate to an increase in GDP? How are they affected by an increase in GDP? Well, the level of investment demand is determined by interest rates, not directly by GDP. So what that means is this is how investment is affected by the interest rate, right? We just learned about this. How is investment determined by GDP? Well, notice that when Michael Scott was making his decision, he wasn't thinking about what the GDP is, right? So whatever the GDP was, what mattered to him was the interest rate. And once the interest rate was 3% or 1% or whatever it was determined at, no matter what GDP was, he was going to buy 2 or 3 forklifts. Similarly, we can think about government purchases. If a government approves a budget of $10 billion, then government purchases are $10 billion, regardless of what happens to GDP. So again, we could sort of think about exceptions to this where there's a recession and the government passes a stimulus package. But in general, we're going to think about government purchases are sort of set in advance and they're not affected by GDP. I think somebody maybe wanted me to go back to here. Probably also want my head out of the way. So again, whatever real GDP is, government purchases are whatever Congress had decided that they were going to be. Finally, we get to net exports. To simplify the model, we assume that net exports are not impacted by changes in real GDP. And this is something that we will adjust later. We're actually later in the semester, we'll talk plenty about trade. That's really, I think it's really interesting stuff to learn about trade. But for now, we're not going to worry about trade. We're just going to say that net exports are not affected by changes in real GDP. So to summarize, investment, consumptions, government purchases, and net exports, there is no direct relationship between real GDP and spending. So we can take that information, and now we're going to go back and look at that aggregate expenditures graph we had and think about how it's going to be affected by these things. And specifically, so once we no longer assume they are zero, let's see how that affects our GDP and aggregate expenditures graphs. So here was the graph we saw last time. As a reminder, this A equals Y, that's our equilibrium condition. That says everything that's produced is consumed. The A equals C, you think about this as how individuals behave. So far we thought about how individual consumers behave, where we have some spending that's independent of consumption, and then as our income goes up, we tend to spend more of it. We tend to spend some of it. All right, well, this was the case, this A equals C, that was when the only thing that we had was consumption. Let's throw some investment in there. Let's say our country had no investment, and now we have some investment because Michael Scott is going to buy a forklift because the interest rates are such. Well, he's going to buy that one forklift regardless of what GDP is, which means that the distance between the two lines, right here, right here, right here, all of those are the cost of one forklift. So, and again, it's a parallel shift because no matter what GDP is, Michael is buying one forklift. So now we have this shift up once we add in investment. Notice that this means equilibrium GDP also changes. It goes from here up to here. We can add in government spending. Now we get GDP to increase more, and add in our exports, GDP increases more. So we get our new equilibrium there. Y equals C plus I plus G plus NX. So this is our equilibrium once we no longer assume that everything other than consumption is zero. Next, let's look at the expenditures multiplier. So what that is, what this idea of multiplier is going to get us to is how some expenditures get multiplied. Let's see what we mean by that. So one thing you could see by the graph, if you look closely, is that an additional dollar of expenditures will boost real GDP by more than $1. Here's what we mean by that. If we look at the graph and we see that, let's say that this right here, Michael Scott spent $100 on his forklift right here. Well, if we look at how GDP changes, equilibrium was right here. Now it goes up to here. So this is how much GDP changed. Notice this line right here is longer than this one right here. Let me erase it. It might make it a little more clear. So where you can compare the two lines. All right. So this line segment is longer. And so, we could go through geometry and explain sort of why the slopes of the line mean this. But that's not the point of this. What we want to think about is the economic reason why an additional dollar of expenditures will boost real GDP by more than $1. This is why you get this idea of a multiplier. Our $1 change and when we bought the forklift multiplies and gives us a bigger than $1 change in GDP. Well, when one person receives income, they spend a portion of it. That spending becomes income for someone else. When the other person receives income, they too spend a portion of it. The expenditures multiplier tells us how much output will eventually increase for any initial change in income. So let me illustrate what I mean by that. So we start off and Michael Scott buys his forklift. And I'm going to tell you that the marginal propensity to consume is 90%. So remember what that means is every time you get $1, you spend 90% of it, save 10% of it. We're still writing here. All right, so Michael bought that $100 forklift. Person who sold him the forklift, they get $100. They spend 90% of that. So we're going to say they spend $90 on a watch. What do we do with the rest of it? The rest of it we save. So marginal propensity to save is 10%. 100 minus marginal propensity to consume. So we're saving 10%, spending 90 bucks. All right, well, the person who sold the watch, now they have $90. They're going to spend 90% of that on dinner, save the remaining 10%, which is 10% of 90 bucks, which is 9%, which is $9. Okay, and keep going. Restaurant owner takes that 81, spends 90% himself, saves 10%, and it keeps going. And so this does not just lead up to infinity. There is actually, if we do the math, we can figure out the total increase in spending. So our total increase in expenditures, which is going to be our total increase in GDP, right? So GDP isn't just the $100 Michael spent on a forklift. It's the $100 he spent on a forklift, plus the $90 for the watch and the $81 for dinner and so on. Well, how do we get there? Well, this is sort of the arithmetic that we did that we would have done in this problem, right? That was adding up all the when we see the hand with the cash in it, when we add up all those 100 plus 90 plus 81, which is 90% of 90% of 100. When we do that, that simplifies out to this right here. 100 times 1 over 1 minus 0.9. 0.9 being the marginal propensity to consume, which is equal to 100 times 10, because this thing in the parentheses here, that's equal to 10, which is 1,000. So that means if we take the amount that Michael spent on the forklift plus the amount that was spent on the watch and dinner and so on, all of those together will eventually add up to $1,000. And so we have this, the more general formula is given right here. The expenditures multiplier, so we call that the multiplier with the little e next to it, is equal to 1 divided by 1 minus the marginal propensity to consume. So our total change in GDP, delta Y, is equal to the expenditures multiplier times the change in expenditures. So here, the expenditures multiplier was $10, or was 10. So that means every dollar that gets spent is multiplied by 10 to give us the total change in GDP. Or every every dollar that one of those expenditures, with that one of the demand increases, so every dollar that we get in investment translates to a $10 increase in GDP. Why are you multiplying? The reason we get this 100 is that was the initial amount spent on the forklift. So that was the initial change in expenditures. All right. All right, so now we've learned about the expenditures multiplier. We're also going to learn about the tax multiplier. So real quick, the MPC, that's the marginal propensity to consume. What share of an extra dollar do you spend? And I said in the problem, in the example, that it's 90%. So the tax multiplier, we haven't really talked much about taxes yet. We sort of assumed them away to zero. But for now we are going to start talking about them. And we're going to think of them very generally as sort of the opposite of what we just solved. So you think about the investment demand was, hey, let's give the forklift company owner another $100 and see what happens. The tax is what we're going to say is like, let's say we take $100 from the forklift company owner. So we tax them $100. Let's see what happens then. Well, the tax multiplier tells us how much output will eventually change for any initial change in taxes. Well, if you're taxed, you decrease your consumption, but you're not going to decrease it by the full amount of the tax. So we think about, it's basically the marginal propensity to consume in reverse. So if you're taxed $100, what we think is that you're going to reduce your spending by $90 and reduce your savings by $10. The tax multiplier is directly related to the marginal propensity to consume because as income decreases, some consumption and some savings will be lost. And it's similar logic to the expenditures multiplier. So suppose the forklift company owner is taxed $100. He'll reduce his consumption by $90. The watchmaker then will lose out on $90 in income. She'll reduce her consumption by $81 and so on. So again, now we're just going in the opposite direction. Taxed 100, reduce consumption by 90. That's lose out on 90 in income, reduce consumption 81, and so on. Okay, so we have another formula. This is for the, we have another formula. This is going to be for the tax multiplier. I'm going to show those now. So the tax multiplier is equal to a negative marginal propensity to consume divided by 1 minus the marginal propensity to consume. So in this case, the tax multiplier is -9. So our total change in GDP is equal to -9 times the amount of the tax. So really there could be a, to be precise, there should be like a negative sign right here, because the change in GDP is a negative number. So GDP goes down by 900. Now, one thing I want to mention is this does not account for the tax revenue being spent by the government, right? So it's not actually the case that the government is going to, take that money and throw it in the ocean or something. We think they're going to take it and use it to spend some money, which, and we'll learn about this later, is that government spending will have a multiplier of its own. Okay? So we're going to go ahead and we'll do one example, and then we will sing the song. We have instruments today, it looks like.
Yes.
So if the marginal propensity to consume is 75%, what is the tax multiplier? And yes, why is GDP in this? Okay. So we just take our formula for the tax multiplier. So we have negative marginal propensity to consume divided by 1 minus marginal propensity to consume. -3/4 divided by 1/4 is -3. So marginal propensity to consume is 75%. Then the tax multiplier is -3.